Hello and welcome to a video about the mechanisms you need to know for the new 2015 Chemistry AS level spec for OCR. This is a new course and it's either the first year of a 2-year course or just the AS level with the breadth and depth exams in the summer. So for the mechanisms for the organic part of the course, there are 3 main mechanisms you need to know. These are free radical substitution being the first one for alkanes. So free radical substitution involves 3 steps: initiation, propagation, and then the termination processes. And for this mechanism you need to know the definition of a free radical, which is a reactive species with an unpaired electron. And these are denoted by an element with a dot that represents a single electron rather than a paired electron. So for initiation, if we take, for example, chlorine, it uses UV light to catalyze a breakdown of chlorine into 2 free radicals. And this is by the process called homolytic fission. The other mechanisms use heterolytic fission, but this is for homolytic fission. So then this free radical goes on to the propagation steps. And let's take the example of methane. First, a methyl free radical forms plus hydrogen chloride. And then the second step of this is this methyl free radical reacts with more of the chlorine, this time the element form, to form chloromethane, and the free radical of chlorine is regenerated. So overall, it's the way you can see it. If you cancel out the chlorines and if you cancel out the methyl free radicals, the overall reaction is CH4 plus Cl2 goes to CH3Cl plus HCl. Then the termination steps, they can be anything, any combinations of 2 free radicals. For example, chlorine plus chlorine free radicals goes to a chlorine molecule, or it can be a methyl plus a methyl goes to ethane, or it can even be similar to the second propagation step, where this occurs and chloromethane is formed. A chain reaction can occur because of the regeneration of this to form dibromo or tribromo or tetrabromo methane. So that is the first mechanism you need to know. The second mechanism you need to know is electrophilic addition, and this is for alkenes, where an electrophile is an electron pair acceptor. The key thing with this mechanism is the curly arrow model, which shows movement of 2 electrons, so an electron pair. So if we take an example of an alkene and hydrogen halide, for example hydrogen bromide and propene, you must always include the dipoles on the hydrogen halide, and the first step in the mechanism is the movement of 2 electrons from the pi bond, and also the movement of 2 electrons in the covalent bond to the bromine. This forms a second product, which is a carbocation intermediate. So this carbocation intermediate would have the hydrogen added, but there would be a positive charge on this middle carbon here. And bromine would now be a bromine ion with an extra electron pair. and this now is the movement of these two electrons onto that positive charge to form the product, which is two bromo propane. Now the reason that the bromine attaches to this middle carbon for the major product is Markovnikov's rule. Now Markovnikov's rule states that the hydrogen, which is this one here, attaches to the carbon with most hydrogens on it. So this hydrogen would attach to this carbon here, which is why the CH3 forms. So the hydrogen goes to the third carbon in the chain, or the first carbon, because it's symmetrical. And this is because this secondary carbocation, where the carbon is a secondary because of these two carbons on either side of it, is more stable. So this carbocation is more stable because it's got two methyl groups which are electron donating. So these two methyl groups temporarily donate electrons, so this carbon here is more stable, which is why it forms a carbocation in this form, and it forms a major product with the bromine left to attach to this middle carbon here. There can also be electrophilic addition where it's not a hydrogen halide, it's a halogen atom. So rather than the HBr here, it would be a bromine, for example, but the pi bond electrons will induce a dipole on the bromine, and then it follows exactly the same steps, but there's a 1a and a 1b step, the 1a being the induction of the dipole onto the bromine atom. The third and final mechanism you need to know for this specification for the AS level, or the first year of A2, is nucleophilic substitution. Where a nucleophile is an electron pair donator. And that's also a definition that you need to know. So nucleophilic substitution, it can be shown in different ways, but for our specification, the OCR specification, it's just one step. So if I take an example here, of a haloalkane, so the chlorine is bonded to this carbon here, there will be a dipole between the carbon and the chlorine atom, and then heterolytic fission occurs in this step, and a nucleophile, which can be anything, for example anything with a negative charge, for example this hydroxyl group here, attacks the carbon at the same time, which forms in one step in this specification an alcohol and a remaining chlorine ion. And this is quite a simple simple mechanism. It's an oversimplified version, but this does get more complicated in the next year, and also with the old syllabus this was different, so that's the main change from the old syllabus.